Welcome to Learning with Homework Elves. Today, we'll be understanding basic concepts in physics on kinematics. That is to say, we'll be learning to describe motion. We'll be touching on terms used in motion and what they mean, how to read some graphs related to motion, and also cover free fall. Let's get started with the basic concepts. What is distance? Distance is the total length traveled, regardless of direction of travel. If you look at the chart from the right, moving from A to B to C to D, the total distance traveled is 30 plus 10 plus 30, which is 70 meters. Distance is hence a scalar quantity. A scalar quantity is concerned only with magnitude. Displacement, on the other hand, is distance moved with reference to a starting position, that is to say, direction matters. Mathematically, displacement is the final position minus the initial position. So looking again at the chart that we just saw, in moving from A to B to C to D, displacement is the distance of D from A, so displacement is 10 meters. Displacement is hence a vector quantity. Vector quantities have both magnitude and direction. Speed measures how fast or slow and is defined as the rate of change of distance. Speed is hence the distance travelled over the time taken. The SI unit, or the International System of Units, for speed is meters per second. Velocity, on the other hand, measures distance travelled per unit time with reference to starting position. It is hence defined as the rate of change of displacement. Velocity hence equals to displacement over time taken. You probably often hear the word acceleration. Acceleration is about speeding up or slowing down. The definition of acceleration is rate of change of velocity, that is to say, direction matters. Acceleration hence equals the change in velocity over the time taken. The SI unit for acceleration is meter per squared second. Let's now look at some motion graphs. Let's get started with the distance time graph, which shows the change in distance over time. The gradient at a specific point on the graph gives instantaneous speed. So if you draw a tangent to the curve and find the gradient at that point, you can determine the speed at the moment. So looking at the graph on the right, to find the speed at point A, draw a tangent to the graph at point A, find the gradient, which is 15, divided by 20 minus 7, and you'll find the speed, which is 1.2 meters per second at that point. The steeper the gradient of the graph, the higher the instantaneous speed. Let's look at more examples of distance time graphs. For A, you will see that the distance is unchanged at 20 meters across time. The object is hence stationary. For B, the distance increases uniformly by 1 meter every second. Speed is hence uniform at 1 meter per second. For C, the object is covering a larger distance per second. The speed is hence increasing and the object is accelerating with time. For D, the object is covering a smaller distance per second. The speed is hence decreasing and the object is decelerating. Let's now move on to velocity time graphs. Velocity time graph shows the change in velocity over time. The gradient at a specific point on the graph gives instantaneous acceleration. So if you draw a tangent to the curve and find the gradient at that point, you would determine the acceleration at that moment. So looking at the chart on the right, to determine acceleration at point A, draw a tangent to the curve at point A and find the gradient to find the acceleration. So for acceleration at point A, it is 50 minus 0 over 34 minus 0, which is 1.5 meter per squared second. The steeper the gradient of the graph, the higher the instantaneous acceleration. Let's look at more examples of velocity time graphs. For A, the velocity is 0 over time and the object is hence stationary. For B, the velocity is at 20 meters per second over time. The object is hence travelling at a uniform velocity with no acceleration. For C, the velocity increases uniformly at 1 meter per second every second. There is hence a constant acceleration of 1 meter per squared second. As you can see, the gradient of the graph is constant. For D, the gradient of the graph increases with time and the object is hence accelerating. For E, the gradient of the graph decreases with time and the object is hence decelerating. Let's now look at the area under a speed time graph. If you recall, speed is equals to distance over time, and if you rearrange this, distance is equals to speed times time. The area under a speed time graph hence gives you distance. To find the distance in the chart on the right, we could use the trapezium formula, which is 0.5 times a plus b times time. So distance travelled by this object in this chart equals to 0.5 times 10 plus 30 times 40, which is 800. Let's now understand free fall, which is also a concept in motion. Free fall takes place when there is no air. That is to say, during free fall, the only force acting on the object is gravity. All objects fall at the same rate, regardless of mass or size. A feather and a stone will hence fall at the same rate during free fall. During free fall, velocity steadily increases at a constant acceleration due to gravity. This is 9.8 meters per squared second. We hope you have enjoyed learning about kinematics with Homework Elves. For personalized help on your schoolwork, sign up today at homeworkelves.com. Thank you for your attention.